When the team at Google created Kubernetes, they paid particular attention to making sure that network communication was as simple and straightforward as possible. For instance, every pod gets its own virtual IP address called a cluster IP. This eliminates the need for port mappings. Furthermore, Kubernetes clusters have a flat network address base. Therefore, you don't need network address translation. These are examples of how Kubernetes simplifies networking. But there's still one big problem. Direct communication with a pod is unreliable. For one, pods are ephemeral. They can be deleted and recreated at any time. Additionally, a pod's cluster IP is not guaranteed to be stable. It could be changed at the most inconvenient time. These problems are bad enough when you're trying to communicate with a single pod. Life becomes a lot harder when you have a set of pods that you need to keep track of. That's why Kubernetes has a component called a service.
A Kubernetes service is an object which acts as a proxy for one or more pods. Conceptually speaking, when you send a message to a service, the service forwards the message to one of its backing pods. Services provide three core benefits. First off, they act as an abstraction layer, simplifying the process of communicating with pods. Second, each service has a stable cluster IP address which remains unchanged for the life of that service. Third, a service acts as a simple load balancer. All traffic to a service gets spread between its backing pods. For older versions of Kubernetes, the traffic is spread out using a round-robin scheme. On modern Kubernetes, the traffic is spread out randomly. Note that the traffic is distributed at layer 4 of the OSI network model, i.e., services perform basic TCP/UDP packet load balancing. Let's go over a little demo. We're going to start out with a deployment for a pod which randomly generates jokes. The joke generator pod has a container which runs a simple server. Every time you hit port 3000, the web server will respond with a JSON object containing the setup and punchline for an amazing joke. The JSON object will also contain the IP address of the pod which generated the joke so that we can see where the message came from. It's set up to run 3 replicas. Each pod runs a single joke generator container. Here's the service that we're going to create. It's named Cluster IP Service. The selector targets all pods with the label pod label equals joke gen pods. This matches the labels of the pods created by the joke deployment. This is how the service selects its backing pods. While we're on the subject of selectors, I want to point out that services do not accept match label or match expression selector fields. You see, services are an older component. As such, they only accept key value selectors in the same style as match label selectors. Let's move on to the ports array. A service accepts traffic on the ports in this array. In this case, the service accepts TCP traffic on port 3000 and then forwards it to port 3000 on the backing pods. Let's test it out. For starters, we need to create the joke generator deployment and service. Notice that it's a cluster IP type service. This means that the service has a cluster IP address and can only communicate with objects in the cluster. Here's what happens when we try and request a joke from the service using curl, which is a utility for making requests to a server. You may have noticed that curl just hangs. It does this because it can't make a connection. You see, the joke service is running on Minikube, which is a single node cluster running on a virtual machine. Therefore, we're curling from outside of the cluster, which means that my requests aren't routed to the service. That's why curl hangs. To curl from inside of the cluster, I created a simple Docker image called Alpine curl. It's just Alpine Linux with the curl and JQ utilities installed on it. Alrighty, here's the curly pod. It runs an Alpine curl container and sleeps a lot. This gives us a chance to use the exec command to get command line access to the container. Let's start by creating the pod. Then we need to establish command line access to the container so that we can curl things. Note, I'll explain how the exec command works when we get to the chapter on kube control commands. Why don't we curl the service now? This time it works because we're curling the service from inside of the cluster. Therefore, curl's request message is properly routed to our joke service. Note, the silent flag removes some annoying headers from the output. I then pipe the results returned by the joke generator server to the JQ utility. This utility pretty prints the JSON response object. Let's run the curl command a few more times. See how we get responses back from other IPs? This makes sense because the service is spreading our requests across the 3 pod replicas.